Why, hello there. I didn't even see you standing there in the corner. You're early. My name is Sir Norrington Applebottom, and this is another episode of Calculus Regressions. Yes. On today's episode, we will be talking about... drum roll, please. Marijuana-related arrests between the years of 2000 and 2008. Right so. Now, for any of you marijuana users out there, you may know that it's a common fact that if you smoke cannabis, your eyes become red and engulfed with blood. Ooh, nasty business. And if you will, on the reverse side here, I've got the data for these regressions. Yes. Stay. I would like to begin today's episode of Calculus Regressions and such by finding my paper. Right so. So, for today's business, I'd like to point out that this is the original graph of my data, and between the years of 2000 and 2008, we've got arrests ranging from the lowest in 2001 being 700,000, 23,600, to the highest being in the year 2007 at 800,000, 72,700. Yes, quite a big difference there. Let's see here. If you notice on this page here, as you won't be able to notice because you probably can't see it, I've got a list, very long, of a bunch of regressions ranging from quadratic to cubic to quartic to linear to ln to exponential regressions. Wonderful. The two that I found to be most useful were the cubic and the quadratic regressions. They most accurately stuck to the data, and they were pretty to look at, as noted here by the cubic regression. When I split the two regressions and fused them much like a nuclear physicist, I used the number 767,200, as noted here, which gave the two graphs a very nice flow, very cohesive. Excellent. Unfortunately, however, as I followed through with the rest of my report, I discovered that nearly none of the regressions worked when taken to the second derivative. Quite a shame. When I later used Newton's method to find the zero for the cubic regression in the first derivative, after 7 iterations, I found on the 8th that the zero would come in the year 2014.3, so approximately sometime in March or April. Similarly, when I was asked to find the average rate of change and the instantaneous rate of change, I found them to be quite near one another, the average rate of change being at 19,825.85, and the instantaneous rate of change being somewhere around 14,000. Not bad. Given those 2 points, the point of intersection again was in 2004.3. Unfortunately, like I said, none of the second derivatives worked on my regressions, and so when plotted I got a line that looked something like this. Much like that. When I did do the cubic regression, I found the maximum for the y value to be at 857,053.7, and the minimum, as denoted here, to be at 712,430.7. Given these numbers, I found the graph to be increasing between the year 2001.4 and 2007.61, along this line here. Similarly, I found the graph to be decreasing between the years of negative infinity, so basically the dawn of frickin' time, to 2001.4, here. Also, I found them to be decreasing between the years 2007.61 and the second coming of Christ, aka the end of the world. Here. Let's see. As noted by these green linear lines, we're in a linear fashion. They're parallel and linear. That determines the area under the curve, which I have found to be equal to 6,216,685.8. That is using, of course, the cubic regression, which, again, was my best regression. And after many arduous calculations, I found the average beneath the curve to be 777,000.725. Furthermore, on the topic of marijuana-related arrests, I'd like to draw your attention back to the front of the board here, so that I may, before we conclude, point out the excellent hand drawing work and the excellent eye coloring work by the world famous pinteur Connor Krusman. If you'd like to take a closer look at those aquamarine eyes, don't you just get lost in them? Lost like a sea captain at sea. Quite wonderful. And so, if we've any further questions or comments about my reports here today, feel free to raise your hand. Now, again, thank you for watching another episode of Calculus Regressions. I am Sir Norrington Applebottom, and I bid you adieu. Shoot, go on, get out now. Go on, get out. I said leave!